Hey friend, today's conversation is all about the unit circle. So grab your favorite pencil or your tablet and let's get started. The unit circle is a circle that is centered at the origin. And we know the coordinate point for the origin is 0, 0 and has radius 1. So what does that mean? That means the center of our circle is right there at the origin. And if I draw any line from the center to the edge of the circle, that distance is 1 unit. Anywhere from the center to the edge, 1 unit. That's what it means to be centered at the origin and have a radius of 1. Next piece of information is the equation for the unit circle. So the general equation for a circle is x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. So for the unit circle, that means we have x minus 0 squared plus y minus 0 squared is equal to 1 squared. This simplifies to x squared plus y squared is equal to 1. So the equation for the unit circle is x squared plus y squared is equal to 1. The next piece of important information is we know the number of degrees in a circle is 360. So there are 360 degrees in a circle. And we know in calculus and precalculus, we speak more in radians than we do in degrees. 360 degrees is equivalent to 2 pi radians in a circle. This means if I travel from my starting point all the way around the circle, I've covered 360 degrees or 2 pi radians. Okay, let's cover a few terms before we get into the details of the unit circle. So the first term we're going to cover is an angle. So an angle has an initial side and a terminal side. So we know an angle looks something like this. It's made up of 2 rays. One ray is the initial side. And the second ray is the terminal side. Okay, when we see our unit circle is made up of angles. The initial side always lies on the positive x-axis, and then the terminal side can rotate around the circle. And when it does so, it creates some angle theta. Okay, so we could also have another angle. Initial side is still on the positive x-axis, but now we've created this large angle that goes all the way into quadrant 3, and that's a different theta. So our terminal side can rotate all the way around our circle. Our initial side stays on the x-axis. Every terminal side has a corresponding point that lies on the circle. So for example, the first angle that we created, on its terminal side, that point where that ray intersects the circle is some corresponding xy. Same with our other angle that we have in quadrant 3. Its terminal side has a corresponding coordinate point. And we know in quadrant 3, x's are negative and y's are negative. We want to keep that in mind the more we study the unit circle, that is an important part of that coordinate point. In addition, every terminal side creates a right triangle with the x-axis. So again, if we look at our first angle, if I go from the point that intersects with the circle and I come straight down to the x-axis, I've now created a right triangle whose height is whatever that y value is and whose base is whatever that x value is. The same thing happens with this terminal side that's in quadrant number 3. I carry my point up to the x-axis. I create my right angle. The height of this triangle is going to be negative y, and the base of this right triangle is going to be negative x. And we're going to use those pieces to see how we find all of the different treasures that are hidden in the unit circle. Think of the unit circle in terms of degrees or radians. If you're in a calculus class or an AP calculus class, you're mostly concerned with radians. If you're in a pre-calc class or you're studying for the SAT or ACT, it's also important to be able to translate between degrees and radians. So for the most part, I'll talk about them both. And if you need to know how to convert between degrees or radians, that's in a separate video. But for the most part, I'll try to write everything in terms of degrees and radians while we study the unit circle. So the unit circle starts at 0 degrees and goes counterclockwise from 0 all the way around. And when we're at the end, that is 360 degrees or 2 pi radians. And 0 degrees is 0 radians. So one complete circle is 360 degrees or 2 pi radians. We focus on the multiples of pi over 2 radians, or 90 degrees, pi over 4 radians, or 45 degrees, pi over 6 radians, 30 degrees, and pi over 3 radians, which is 60 degrees. So the entire circle is made up of multiples of those 4 angles. So we'll start with pi over 2, and then we'll work our way all the way through the other 3. We are going to start building our unit circle with the angles that are multiples of pi over 2. It's the same thing as saying multiples of 90 degrees. I've already labeled where the multiples of pi over 2 are on the unit circle. They are on our axis. So let's start building our angles. So we remember initial side is always on the x-axis. Terminal side is where we create the angle. So from 0 all the way here, we create a 90-degree angle. Okay. Now we already know the radius of our unit circle is 1. So the points, the coordinate points that correspond with pi over 2 should be intuitive. So on the terminal side of pi over 2, that should be the coordinate point 0, 1, because we know the radius is 1. And so because we went from the center all the way to the circle, that's the coordinate point 0, 1. Okay, next we'll make pi. Initial side is still on the positive x-axis. And now terminal side is on our angle pi, or 180 degrees. So the theta we've created is this large angle here. And again, because this is straight on our axis, this coordinate point is -1, 0, because again, our radius is 1, and we're going in the negative direction. Initial side on the positive x-axis, terminal side pointing at 3 pi over 2. Again, creating an angle that's 3 pi over 2 radians, or 270 degrees. This angle is also intuitive. This coordinate point, sorry. This is 0, -1. And last, initial side on the x-axis. And then if I come all the way around, my terminal side is also on the x-axis. And that coordinate point, also intuitive because it's on the axis, should be 1, 0. So 0 degrees and 360 degrees, or 0 radians and 2 pi radians, share the same coordinate point, which is 1, 0, because they have the same terminal side. Okay, now we're going to discuss when theta is a multiple of pi over 4, which is also 45 degrees. So I've already listed out the multiples of pi over 4 between 0 and 2 pi. And I've also crossed out the ones that simplify down to a theta we've already covered. For example, 2 pi over 4 is equivalent to pi over 2, which we've already covered in the multiples of pi over 2. So you will never be faced with a question that's asking you to find cosine of 2 pi over 4, because it would ask you what is cosine of pi over 2. So if your theta simplifies down to an angle we've already discussed, there's no need to cover it in that section. So in pi over 4, There are 4 angles we're focused on. Pi over 4 is in quadrant number 1. 3 pi over 4 is in quadrant number 2. 5 pi over 4 is in quadrant number 3. And 7 pi over 4 is in quadrant number 4. The quadrants are very important because they help us identify the sign of our coordinate point. So we'll start by creating the angle pi over 4. Initial side is on 0, and terminal side is at 45 degrees. So this is our 45-degree angle, or our pi over 4. I don't know why that degree was there with the pi over 4. Please ignore that. Pi over 4 radian. The coordinate point that corresponds with this angle is radical 2 over 2, comma, radical 2 over 2. Again, we're no longer on the axes, so even though the radius is still 1, so the length here is 1, the coordinate point that corresponds to that, remember we make our triangle. So the x value would be whatever this length from 0, 0 to the foot of my triangle, and whatever the height from the x-axis all the way to my corresponding coordinate point. If you want to know where radical 2 over 2 and comma radical 2 over 2 comes from, you can check out my special right triangle video, but we won't go over that here. So the beautiful thing about the unit circle is any other angle that has a denominator of 4 will have the same coordinate point, but the signs, positive or negative, for the coordinate point need to make sense in the quadrant they lie in. So let's move over to 3 pi over 4. Initial side is on 0. Terminal side is on 3 pi over 4. 3 pi over 4 creates this angle here, lies in quadrant number 2. In quadrant 2, x values are negative and y values are positive. So the coordinate point on the terminal side of this ray is going to be negative radical 2 over 2, comma, positive radical 2 over 2. Okay, moving to the next. Initial side is on 0. Terminal side is on 5 pi over 4. The coordinate point that corresponds to this terminal ray is in quadrant number 3. In quadrant 3, x values are negative and y values are also negative. So this is negative radical 2 over 2, comma, negative radical 2 over 2. Okay, last we have 7 pi over 4. Initial side is on 0. Terminal side on 7 pi over 4. So this creates this big, large angle here. The coordinate point that corresponds to 7 pi over 4. In quadrant 4, x's are positive, but y's are negative. So this is going to be radical 2 over 2, comma, negative radical 2 over 2. Now, as you're working to memorize the unit circle or understand the unit circle, visualize the multiples of pi over 4 as cutting the quadrants in half. So they go right through the middle. As you can see, 45 degrees is half of 90 degrees. So it should go straight through the middle of each of our quadrants. And I forgot to draw the angle for 5 pi over 4. I'm just going to do that quickly. There. Now we're going to focus on the angles that are multiples of pi over 3 radians or 60 degrees. So again, if something simplifies down to something that we've already discussed, then we don't discuss it in this section. So 3 pi over 3 simplifies down to pi. We would only ask questions about pi. We wouldn't ask questions about 3 pi over 3, similar to 6 pi over 3, which simplifies to 2 pi. So again, there are 4 angles that are multiples of pi over 3 that we're going to discuss. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So we'll start like normal with pi over 3. Initial side on the positive x-axis, terminal side on pi over 3 radians or 60 degrees. So this is our angle that we've created. Remember, there's always a corresponding right triangle, and that's where we get our x and y coordinates from. So the coordinate point that corresponds to pi over 3 is 1/2, radical 3 over 2. Again, if you're curious where those numbers come from, you can check out the special right triangle video. Again, similar to the other angles, all of the other angles use the same coordinate point. It's just the sign needs to match the coordinate that the terminal side lies in. So 2 pi over 3 is in quadrant number 2. So initial side is on positive x-axis. Terminal side flows at 2 pi over 3. So that means that the corresponding coordinate point that lies on this terminal ray, quadrant 2, x's are negative, y's are positive, is going to be negative 1/2, radical 3 over 2. For this angle, theta equals 2 pi over 3, or 120 degrees. Our next angle, 3 pi over 3, we don't bother with because we've already discussed that. So we're going to go to 4 pi over 3. Initial side on the x-axis, terminal side at 4 pi over 3, creating this angle, 4 pi over 3 there. So the corresponding coordinate point in quadrant number 3, where x's are negative and y's are also negative, is going to be negative 1/2, negative radical 3 over 2. Last, 5 pi over 3, which lies in quadrant number 4, initial side on positive x-axis, terminal side at 5 pi over 3. So the coordinate point that lies on that terminal ray in quadrant 4, where x's are positive and y's are negative, it's going to be positive 1/2, negative radical 3 over 2. Again, like I told you with pi over 4, when you're taking a test or you need to remember the unit circle best, remember the pi over 3s are the rays that are close to the y-axis. So if you look at the rays, they're closer to the y-axis than they are to the x-axis. So that's how I picture them when I picture the unit circle. I forgot to draw my angle for 5 pi over 3. We'll go back and add that in. Okay, last set of angles we're going to discuss are the multiples of pi over 6. Pi over 6 is actually the entire unit circle. As you can see, a lot of them simplify down. And we're not going to cover the ones that simplify down because we've already covered them. I'm going to focus strictly on pi over 6. Again, notice the pattern. The 6 are the ones that are close to the x-axis. So all of the 6 in each quadrant are closer to the x-axis than they are to the y-axis. So when you're trying to use your visual memory, when you're picturing the 6, know that they're the rays that are close to the x-axis. So let's start like we usually do in quadrant number 1 with pi over 6. We'll have our initial side on the positive x-axis, terminal side at pi over 6. And just to show you in quadrant number 1, remember our x and y values come from the triangle that's created with the terminal side and the x-axis. So the coordinate point that corresponds to pi over 6 is radical 3 over 2, 1/2. Okay, remember for the rest of the angles in each quadrant, it'll be the same coordinate point You just have to make the signs of the coordinate point make sense. So 5 pi over 6 is in quadrant number 2. Draw our initial side and then our terminal side at 5 pi over 6. In quadrant 2, x's are negative and y's are positive. So the coordinate point that corresponds with 5 pi over 6 is going to be negative radical 3 over 2, comma, 1/2. Moving on to quadrant number 3, which is 7 pi over 6. We draw our initial side and then our terminal side is in quadrant number 3. So the coordinate point that corresponds to it, where x's are negative and y's are also negative, is going to be negative radical 3 over 2, comma, negative 1/2. And our last sixth is 11 pi over 6, which is in quadrant number 4. So we draw our initial side and our terminal side. And I haven't been drawing my angles, but we'll go ahead and do it for that one. So 11 pi over 6 is in quadrant number 4, where x's are positive and y's are negative. So the corresponding coordinate point is going to be radical 3 over 2, comma, negative 1/2. I'm going to go ahead and draw in the rest of my angles. And that concludes how you construct the unit circle. Remember, if you can draw it and construct it yourself, you'll never forget it. It's a much better way to learn the unit circle than to try to memorize it already constructed. Good luck studying.